Okay, let us start our discussion on Cauchy's mean value theorem. What the theorem tells? This is very important theorem. Let f and g are the continuous function on a closed interval. They are continuous in that interval. There no means there is no gap and all those things. The function is defined everywhere, all like that, and differentiable. Okay, that means differentiable means left and right hand derivative exist on this interval in excluding endpoint like that, and g dash of x is not equal to 0 means first derivative of second function, that is g, is not equal to the 0. Then x is belongs to open interval. There exists a, you have to prove that such that f of b minus f of a divided by g of b minus g of a is equal to f dash of c divided by, you have to prove. First, okay, what we can do here, we already know the Rolle's theorem. We are going to apply the Rolle's theorem in order to prove this one. You have to prove this one. There exists a c in between the intervals such that the c exists like that. Okay, if you have to prove like that, f of b minus f of a divided by g of b minus g of a is equal to f dash of c divided by g dash of c. How can we prove? Very simple. We consider a auxiliary function. This auxiliary h of x is equal to f of b minus f of a into g of x, like minus of g of b minus g of a into f of x. Okay, now what happens? This is the entire function is there. No, here the f of b is constant, f of a is constant, g of x is continuous, and f of x is continuous and differentiable in open interval. This entire function h of x is also continuous in a closed interval a comma b and differentiable in open interval a comma b. Therefore, check h of a and h of b. H of a, if you calculate it, this is like this, and h of a means in the place of x we have to put a, that's all. F of b minus f of a into g of a, like that. After computation, what happens? This h of a is equal to h of a is equal to h of b. You can get they are equal. Now, once the function h of x is continuous in a closed interval, differentiable in open interval, and h of a is equal to h of b, what happens? You can apply this Rolle's theorem. By that, there exists h dash of c is equal to 0. Now, if you want, then in our before applying h dash of c is equal to 0, you have to find out h dash of x. Just if you differentiate this function, and then what happens? We can get after this constant f of b minus f of a is constant, keep aside, and g of x is differentiation is g dash of x minus g of a, g of b minus g of a is constant, and if you differentiate it, this becomes f dash of x. Then by putting x is equal to c, you can get like this. Rearranging that, we can easily prove this one. Rearranging this, f of b minus f of a into g dash of c is equal to g of b minus g of a into f dash of c. After calculation, you know that whatever we already given, g dash of x is not equal to 0. Okay, for every x belongs to this ab interval, therefore c lies between these things, because we already know that by Rolle's theorem c is lies between ab. Therefore, g dash of c is also not equal to the 0. Okay, now we can conclude that by dividing, then g of b is not equal to g of a. Then okay, then afterwards, means what we can say, um, then by we you can like that, finally we can get rearranging this, we can get, this is how we can prove. Very simple logic. Only you know that the Rolle's theorem, you should know the Rolle's theorem. Based on that, we can easily prove this one. Thank you.